Today we are going to continue with arithmetic progression. Look at this sequence of number. It's 1 to 10. And I want you to add up 1 to 10. Of course, we can do it the old way. 1 plus 2 plus 3 plus 4 plus 5 and so on. But then there is another way of doing this. Look at this diagram. In this diagram, we have 1 dot to 10 dots. We can picture another inverted triangle up here. The total number of dots in this rectangle is going to be 10 times 11. This 11 is the sum of the first term plus the last term. We are going to use A to represent the first term and L the last term. 10 is the number of terms. We use N to represent number of terms. But then, remember that what we want is actually to add up 1 to 10 only. So we are going to divide this 10 times 11 by 2. So here is our equation for adding up this arithmetic progression. Sn, that is, the sum of an arithmetic progression with n terms, equal n times a plus l over 2. Now here we have this arithmetic progression, 51 to 100, and we want to add up all these terms. And we are going to do it using the way that we have just learned. But this time we are not going to use diagram. We are going to use numbers only. So here is going to be 100, 99, 98, until 51. So 100 plus 51, we get 151. This one also 151. This one also 151. This one also 151. And that's going to be 50 of this 151. So the number of terms for this 151 and is 50. The sum of this third row is going to be 50 times 151. 50 is this one. There are 50 terms of 151. And this 151 is actually 100 plus 51. 100 is the last term and 51 is the first term. So we can see that we have n times a plus l. But then what we want to add is actually 51 to 100 only. That's why we are going to divide this whole thing by 2. So for the n, we are going to divide it by 2. So again, we have the same equation. The n here is the number of terms. A is the first term. And L is the last term. And this one, we are going to get 3,775. Right. Last time we have learned that Tn, that is the value of the nth term of an arithmetic progression, is given by this. Today, we have learned that the sum of n term in an arithmetic progression is this one. Now, L actually is Tn. Why do I say so? Let's say I have an arithmetic progression. T1, T2, T3 until T20. Now if I want to find the sum of all these terms in this arithmetic progression, that is S20, because there are 20 terms in this arithmetic progression, then the last term of this progression is T20. So if I want to find S20, the last term is T20. So L here is actually Tn. If you want Sn, the last term L here is Tn. So in that case, we can substitute this one with this. So we have now instead of Tn, instead of L or Tn, we are going to put in this one. Plug in this one. A plus n minus 1 times d. So this is also Sn. So here we have two equations. The first one is this one, A plus L. The second one is this one. If we know the value of the last term, L, then we can use the first equation. If we do not know the value of the last term, we have to use this equation. Actually, this equation is more commonly used. Find the sum of the first 18 terms of the arithmetic progression. For this question, we have n. n is 18. We also have a. a is the first term, and the first term is 11. And we also have d. d is the common difference, and it is -7. Now let's call up the equation to find the sum of the first nth terms. We can see that with the value of n, a, and d known, we can straight away use equation 2. We do not use equation 1 because we do not know the last term, L. N is 18. We plug in the number. A is 11. We plug in the number. D is -7. We plug in the number. And we get -873. Find the sum of all the terms in the arithmetic progression. Now there are two equations to find the sum of the first nth term of an arithmetic progression. For the first equation, we need to know the value of variables n, a, and l to find the answer. For the second equation, we need to know the value of variable n, a, and d to find the answer. Let's look at the arithmetic progression. We have no problem with A. A is the first term, and it is -14. We also know the last term, L. L is 58. We can find D also. D is the common difference, and it is 8. But we do not know N. If -14 is T1, -6 is T2, 2 is T3, then 58 is Tn. And we want to know N. What we need to do is to find the value of N. We are going to use the equation that we have learned earlier to find N. Right, Tn equal A plus N minus 1 times D. Now Tn is 58. And we also substitute in the value of A and D. A is -14. D is 8. And we solve the equation. We get N equal 10. Now that we already got the value of N, we can actually use equation 1 or equation 2 to find the value of Sn. Let's say we are going to use the first equation. We simply substitute in all the values into the variables. N is 10. We plug in the number. A is -14. We plug in the number. L, the last term, is 58. We plug in the number. And we get answer 220. We can also use the other equation. If we substitute in the values of N, A, and D, we should get the same answer.